Morning to everyone. Many thanks for being here, and many thanks to the organizing committee for inviting me to speak about the EDGG activities on Palearctic grasslands. The Palearctic biogeographic realm comprises more than one-third of the world's highest free terrestrial surface and spans a wide range of climatic and topographic gradients. Around 22% of the Palearctic is composed of various grassland types, some of which being the world record holders of small grain vascular plant diversity. A large proportion of the Palearctic grasslands are primary grasslands, such as steppes or Arctic alpine grasslands. Even in regions where the potential vegetation is forest, natural grasslands can occur in azonal and extrazonal conditions. Moreover, as we can see from this slide here, agricultural activities and pastoralism, long present in the Palearctic, resulted in the creation of secondary grasslands dependent on human land use that prevents succession towards shrublands or forests. Particularly the slash and burn practice contributed to the creation of many grasslands all over the Palearctic since prehistorical times, to the detriment of the woody vegetation. Here you see the landscape around the ancient town of Mycenae in southern Greece. Despite the town has been abandoned a long time ago, about 2000 years ago, the land use surrounding the town has been managed in a very traditional way until a recent past. Terraced fields, partially with olive groves next to the town, and rangelands on the mountain tops. In recent times, grasslands face multiple threats, including area loss due to transformation into arable fields or built-up areas, but also altered management by intensification or land abandonment, that is, the cessation of traditional management systems, as we can see here in the landscape surrounding the ancient town of Mycenae. This is a pity, because grasslands are a very important cultural asset for the human civilizations. Describing biodiversity patterns and understanding the drivers and processes behind are essential needs for an effective conservation and restoration of natural and semi-natural grasslands. For all these reasons, the Eurasian Dry Grassland Group, that is the EDGG, was established in 2008 as a free network of scientists and conservationists interested in Palearctic natural and semi-natural grasslands. The EDGG is a working group of the International Association for Vegetation Science, and it is also a member of the European Forum for Nature Conservation and Pastoralism. Anyone interested in grasslands and rangeland knowledge and management is cordially invited to join the EDGG. The membership is free of charge, you don't have any obligations, and instead you have some facilities that include, for instance, the publication of an open access journal that is titled Palearctic Grasslands, but also the organization of annual meetings and research expeditions in various locations of Eurasia, North Africa, with the aim of sampling highly standardized, multi-scale and multi-taxon vegetation plots. During these expeditions, we collect biodiversity data with a nested plot sampling design. We have a spatial data collection form for such a purpose, as you can see, and you can find plenty of infos about the EDGG sampling methodology in this paper here that you can easily retrieve and download from our website. The EDGG activities largely contributed to the assessment of biodiversity patterns and species area relationships in the grasslands of many different areas, as you can see from a few recently published examples. And the EDGG activities contributed to provide a significant baseline for overarching synthesis about the Palearctic natural and semi-natural grasslands, because all the data collected are stored in GrassPlot. That is the EDGG associated database of multi-scale vegetation plot data of Palearctic grasslands and other open habitats. It's important to know that everyone can contribute to GrassPlot. It is enough to have data collected on precisely delimited surface areas on at least 4 grain sizes. You can find the GrassPlot bylaws and all other relevant information at the link reported here below. Now, I would like to present some examples of the many outputs coming from the EDGG activities and from the GrassPlot database. First example is about alpha diversity of plant communities. This is an issue that, as we know, has always attracted the curiosity of scientists. It is of great importance to understand patterns of community assembly, species pools, and so on. And some years ago, Wilson and others published richness records at global scale for areas from 1 square millimeter to 10,000 square meters. They showed that temporary grasslands are the richest plant communities for areas smaller than 100 square meters. Afterwards, even more world records at small grain size have been discovered for Mesoxeric grasslands in White Carpathians. However, there are also some species poor Palearctic grasslands. In any case, maximum and minimum richness values are only a small part of this story. The EDGG activity and the GrassPlot database provide the basis for a robust knowledge on plant diversity in the Palearctic grasslands, with many replicates from many different areas and habitat types. Moreover, it is well known that richness of vascular plants, bryophytes, and lichens is not congruent across vegetation types. The data sampled during the EDGG expeditions allowed the assessment of vascular versus non-vascular plant diversity, referring both to bryophytes and lichens. As plant diversity is strongly dependent on spatial scale, we also aim at providing benchmarks of plant richness values of different Palearctic grassland types across different grain sizes, from 1 square centimeter to 100 square meter. Here you can see the current geographical distribution of the data stored in GrassPlot. As you can see, the highest density of plots was recorded in temperate Europe, whereas a large amount of Asia is still blank. Here you see the data availability for different standard grain sizes, the distribution data across different vegetation types, and with the collected data, it is possible to account, for instance, for the mean species richness of vascular plants of different vegetation types for standard grain sizes, or also to account for the differences across regions of the same vegetation unit. In this case, the richness values of Mesoxeric grasslands in different geographical areas. It is possible to account for the difference in species richness between vascular plants, lichens, and mosses in different vegetation units, and also in different regions. A new open access tool stemming from the collaborative network between the EDGG and GrassPlot is the GrassPlot Diversity Explorer, which allows dynamic online queries and analysis of the up-to-date content of GrassPlot database, including descriptive statistics for grassland diversity in any combination of grain size, taxonomic group, biogeographic region, vegetation type, This tool was created by Remek Pilek, that you see here in the pitch, in this pic, and we all gratefully acknowledge him for making the GrassPlot Diversity Explorer available. But alpha diversity is only one part of this story, because nested plot sampling design is also very useful to study the variation in species area relationship, for example, basing on the Arrhenius power law, which is a very well-known formula in which S is the number of species occurring in a given territory, A is the area considered, C and Z are empirically determined parameters. In particular, C expresses the number of species per unit area, and it is largely dependent on the phylogenetic and paleo and biogeographical history of a given territory, whereas Z, the Z value here, the Z exponent, expresses the increment of the number of species along with the increase of the area. And the Z value is largely depending on environmental drivers, such as land use or slope, as you can see here, or microrelief, that is a good proxy for the within-plot heterogeneity in land morphology. One major achievement that involved the great wealth of the EDGG members was the curatorship of 13 regional chapters, totaling 183 pages and covering the whole Palearctic biogeographic realm in the Encyclopedia of the World's Biomes. That is a comprehensive work consisting of 5 volumes, which have been published in spring 2020. But there is more. Besides of a sound scientific basis, beyond the many so far published achievements, what makes the EDGG a very special place are the enthusiasm that unites all of its members, the many friendships born in the field, the tight collaboration in the common project to enhance and protect the many species that make grasslands so beautiful. We very much hope that this first international conference on range management in Iran will strengthen the ongoing research network and start new fruitful scientific cooperation with colleagues from Iran and neighboring countries. A very good next opportunity to meet could be the forthcoming Asian Grassland Conference that is organized as an EDGG online event from February 22nd to 24th, 2022, to which all of you are cordially invited. The conference will probably take place on a Zoom platform on a 3-half-day basis, and further details will be announced in the EDGG website and in the journal Palearctic Grasslands. In such event, we very much hope to meet many researchers from Asia working on grassland research, management, and conservation, and we are looking forward to starting new friendships and collaboration. Many thanks to all of you for your kind attention.